Thanks for coming out, everybody. How many people here have dabbled or worked on blockchain so far? Cool, small hand. How many people think it's a terrible technology and a worse vision for the future? Okay, a friendly audience.
No one needs to be thrown out, right?
Great. So this is a new topic for us, but as I've gotten to know Ed, we've kind of discovered both a lot of, parallels to the hype and possibilities around AI and machine learning with the hype and possibilities around blockchain, and also a lot of differences. So Ed Greenwood, he's currently a technical fellow at Eastern Labs, which is part of Eastern Bank, which is 200 some odd years old.
Yes.
And he's responsible for identifying and researching not just blockchain and things that you might build on top of blockchain, but innovative and emerging and disruptive technologies. And he's been doing this computer thing for quite a while, from scraping e-commerce results off the web in the 90s. You did, was it a nutrition database and stuff? So he's doing a lot of stuff around this, and we'll kind of touch upon some of the stuff that he's done with, for example, using blockchain for securitized loans and stuff like that. So everyone, please give a big hand for Ed.
Thank you. Thanks for having me today.
Yeah. So upfront disclaimer, Ed is here. His opinions are of his own. Tonight, he's not speaking on behalf of Eastern Labs or Eastern Bank. But boy, his opinions. Cool. So hi, Ed. Welcome.
Thanks.
So when did you get into blockchain, and why?
Well, I heard about blockchain way back, right around 2010. My brother was actively trying to mine Bitcoin, believe it or not, and that was when Bitcoin was worth 0.008 cents per coin. And by summer, it rose to 8 cents a coin. And then by the end of the year, it rose to almost a dollar a coin. And it sort of put it on the map. And so I started hearing about, in my circles, I read a lot of computer science journals. I started hearing about blockchain, but I didn't really pay attention to it. And from 2002 until 2015, I ran my own business. I started a self-funded company, initially to mine data off websites and sell that to Wall Street. And along the way, over the next 10 years, I created a bunch of what I thought were pretty innovative apps for every device out there, from BlackBerry to Palm Pilot to today's iPhones. And in 2015, I got a call from State Street. They were looking for a guy. They said they want someone who has the trifecta. I didn't know what that meant. They said they're looking for a guy that is an entrepreneur, an innovator, and a software generalist that's done a lot of different things in software to work on blockchain and to research emerging disruptive technologies. And so I took the job, and I started off as the lead architect of the new Emerging Technology Center at State Street. And our first project was blockchain. They asked me at the interview, and then later said, we want you to digitize a syndicated loan. Take a syndicated loan and place it on top of a blockchain, which now it seems simple, but it wasn't at the time. No one understood, can you represent money on blockchain? Can this be done?
This was before Ethereum, right?
This was when Ethereum had
just come out.
Just come out. It was the first time Ethereum was really usable. So Ethereum came out in 2014 when they had their big launch, but it wasn't publicized. There weren't examples. You couldn't do much as a third party until about 2015. So
and then, you're talking about blockchain. When you say blockchain, what do you mean?
Blockchain. We should start with the definition of blockchain. I know you hear this a lot, and there's answers all over the internet. And every time I get on, it's different. Even Wikipedia has changed a number of times the definition of what they call blockchain. But in layman's terms, blockchain can be defined as a distributed, decentralized database that maintains a continuously growing list of records, which are known as blocks, and each of those blocks is cryptographically linked to the previous block.
That's the layman
That's
term?
like the that's the best I could come up with today. That's in a nutshell. Without they have whole paragraphs just defining it. But
so it means that every record or block as a specific parent.
Yeah, so every record, and think of people that know database, they understand records. So sometimes I like to use the word record. A block is like a collection of records. It's a collection of data, and usually it's done by time. So like with Bitcoin, it's every 10 minutes. Every 10 minutes, they look at all the transactions that happened worldwide. Someone might have bought a bicycle. Someone might have bought illicit drugs. They don't care what you purchased. They're only interested in verifying those transactions. And when they're verified and organized by time, they're placed into a block. And the block is sealed, and they begin to work on the next block. So a blockchain, one interesting difference between a regular database and a blockchain is it never stops growing. So even if there's no data to store, the database keeps growing by one block. Could be every 17 seconds, could be every second, could be every 10 minutes. But you have this notion of chunks of data that are related. And one of the early strengths of blockchain was that each block, they're linked to the previous block. They use a hash code. They calculate a hash code is like a 32-character number, an alphanumeric string that represents something like a piece of data. So for like War and Peace or a massive book, it would still be like say maybe like 64 characters.
It's derived from that data.
Yes.
Right. So it's intrinsically linked.
So the name Ed is also 64 characters. But if I ever change anything in that book, if I change just one letter in that book, like a capital I to a lowercase I, the hash code won't match anymore. It'll be radically different. But as long as I never change the book or the content, the hash code's always the same. They take all the transactions that happened in the last 10 minutes, this is for Bitcoin, and they calculate a hash, and there can be it'd be impossible to calculate that any other way. It's a unique number. And they put that hash in the next block. So every block has the hash from the previous block in it. So to change something, to alter the database, you'd have to go back years, change all the blocks, and no one, even Google, said we don't have the computing power.
And then you have to redo all the work. So the larger the blockchain, the harder it is to fake it.
Right. And so I guess we could get into, well, I'll let you.
Can we, am I allowed to ask you about the time you got uninvited to give a talk?
Oh, we've been a couple times before this just to talk, and I said, I like to take a sort of a generalist stance. I like all blockchains. I keep an open mind. But I was one time I was invited to a blockchain talk, and at the last second they told me I can't go because they wanted me to say that Hyperledger is the best one and the only usable blockchain on the market. And I said I just can't do that. There's just so many great blockchains out there. Each one has something unique. It's like the first search engines. It's like anything new, there'll be a bunch of players. I know Google started, there were 22 players out there purporting to have search engines, but eventually they overcame them all and became the #1 search engine. But these are early stages, so you can't rule anybody out. But some people, for political reasons and because they have a vested interest in something, they do that. And also there's a school of thought that says blockchains can only be used for real if they're private. So the banks and financial institutions for a long time now believe that we can't use a public blockchain, it has to be a private one. That means it's a database in your own house, you know everybody who's on it. And I think that's wrong. And now that opinion is becoming, it's supported now by a lot of experts. The community now believes that it'll be a hybrid approach. You'll have a mixture of public and private blockchains, the best of both worlds.
Can you expand on that again? Like what is the difference between private, public, and hybrid?
Sure. So first we began with a public blockchain. So the best example is Bitcoin, although it's not the first example. The first working blockchain, and I verified this, I actually brought the article with me. There was a Wall Street Journal article last June that talks about 30 years ago, these two guys in New Jersey created the first blockchain. But they were missing one thing, they were missing proof of work. But they essentially had a working blockchain that all of today's blockchains are built upon. The idea was you have, it's distributed, it's decentralized. If I store something, it can't be erased because there's so many copies out there and you don't know where they are. It's impossible to erase them.
So what you kind of like have a working hypothesis on blockchain. You mentioned like distributed, decentralized, continuously grows. Like, I don't know, how do you think about these kind of emerging technologies in their early stages?
I think, sorry, getting back to your first question, I didn't properly answer the last one about permission. So private blockchains are called permission blockchains. They're only used in-house. You know who's on it. You know all the participants. Public blockchains are out there in the open. You don't know the participants. Anybody can participate. But as a result, they have to be more secure. They have to use more protocols to guard against data theft and fraud, whereas private blockchains don't have to do that. And so they run faster because they can yank out all the security. They can take out consensus mechanisms and take out normal things you'd have to have on a public one. And the hybrid would be, usually they support both. And and the idea is like you do all your stuff in-house. Then when you want to share results with the public, you put like a token on the public blockchain. So you'd have your private blockchain running in-house, doing all your day-to-day functions. And then but at some point during the day, you'd share results on a public blockchain. Proof that you did the work, proof that that program ran, proof that that the database has not been tampered with.
So it's kind of like a press release.
Yes, sort of. And anyway, those are the three types of blockchains.
Okay, so public, and I guess a public blockchain, you'd be looking to more leverage like a network effect.
Yes, and that's the problem with the private blockchain. You're not going to get that network effect. And so it's like the internet. In the early days, most corporations thought that I like the internet, we like the internet, we support it, but we don't want to do the public internet. We're going to have our own private intranet. So back in the 90s, all the big corporations had their own intranet. So they're like, no, we can go to our webpage to see the weather. You want to get a movie? Go to our webpage, you can get a movie. But it doesn't work. And so at some point, like my cell phone would be worthless if I was the only guy that had one. It would be worthless. But until you get everybody participating, that's the network effect. Once everybody has a cell phone, or we all millions of people with an iPhone, then it becomes valuable. And suddenly the value goes through the roof. And so that's why a permission blockchain by itself probably won't stand, because you won't get that network effect where you have the entire global economy using the system to improve trade and commerce and payments. You can.
So the question was using permission and private interchangeably?
That might be the future. The future might be to have your own private blockchain in your bank or in your corporation, but then when you want to share data with the outside world, you'd place like a token, proof that you did something, proof you ran a program perhaps on the public blockchain. You might see something like Ethereum sort of be this middle ground where you can share data with other private blockchains. So now they're designing like Ethereum, they're redesigning Ethereum so it can have a switch to do both. They'll have a private mode and a public mode to it.
Because it's open source, so I can run it locally as a private mode.
Right, and for testing, it's perfect. Like there are many reasons why you might want a private one. It's perfectly valid, but it's very hard to beat a public blockchain. It's to date with today's technology, you can't. No one's ever corrupted Ethereum. No one's ever hacked Bitcoin, and they try around the clock. And they haven't succeeded because of the nature of how it's set up. You wouldn't have that with a permission blockchain.
So you've mentioned Bitcoin, and we touched upon Ethereum, but like, what are some of the popular public and private blockchains?
Well, the list is getting shorter. I spent about 3 years when I worked at State Street I created and I maintained a matrix comparing all the blockchains out there. And it was 2 pages in a spreadsheet breaking down everything from what technologies they use to the layers they use. And now and this is a good thing. It started off, there was, I think the last time I checked, there were about 27 out there. And now there's about 3 good open source ones now. And maybe Intel might be on the list as number 4. But it's really Ethereum. It's free, it's open source, it's public. And then there's Hyperledger, which is not open, it's open source, but it's not a public blockchain, it's a private one. Then there's but I guess in the future they'll have modes to talk with public blockchains. And there's Corda. Corda was created by a consortium of banks, to which my previous employer was a part. More than 80 banks joined forces to try to understand this new technology called blockchain. And they put away their differences and they agreed to work together. And it cut the cost for all of them. It cut the cost of experimenting and made it faster to get ahead of this. And so in the end, this is R3. And in the end, R3 produced Corda, which is their own blockchain designed for financial services.
And then Ethereum is the smart contract
and they all
platform, right?
Yeah, they all now claim they can run smart contracts, but there's big differences between them. It's like Hyperledger, it only runs. They might be changing this, but it really ran like one smart contract. They call it chain code. The idea is it's very open. You can do almost anything you want with it, and they support multiple languages. Then Ethereum said, no, we're going to take a different approach. It's really come down to really one language now. There used to be three. Now it's primarily Solidity. You have to learn this new language called Solidity. And it's very locked down. It's very orthogonal. And they say when you're programming a smart contract, you program like you're programming a 1999 cell phone. It's designed to be that way. It's very primitive on purpose. It doesn't even support, even the new release says it supports floating point, but it really doesn't. And then Corda is a little bit different. Corda supports a hardened version of Java called Kotlin. It runs on top of the Java virtual machine. And they focus on making a language that's predetermined. So I can look at your code and in advance, there are no surprises, I can see what it's going to do. And they have a unique approach where I run the program on my node, and then you run the program on your node, and we compare the final frozen state of that program. Java has a feature to serialized code. You can freeze the running state of a program, and then you can convert it to a big text file, basically. And the other side can do that too, and they can compare. And that's how they achieve consensus. They can both agree on the result, that the final state is the same.
And presumably because it's including what's in memory and stuff like that.
So
it's almost like how they got there as well.
And these are, everybody's taking a different approach. And then the fourth one was Sawtooth Lake, which is Intel's product. And they have a very clever approach. They require hardware. And they do something called, we can get into consensus later. We probably have to give it a good definition. But they use something called proof of elapsed time, which is very clever, to get rid of all the wasted energy that happens when proof of work takes place.
So what's proof of last time?
So proof of elapsed time means whoever's timer expires first gets to vote first. So in a timer, it could be a fraction of a second, but you don't know whose timer is going to expire first. They're trying to replicate proof of work on Bitcoin, where I'm not sure the level of the audience, what everyone knows about this, but one of the special things that makes Bitcoin work, that makes blockchain different than a regular database, is in order to make a change to it, it has to be voted on. They call that consensus. So with things like Bitcoin, every 10 minutes there are a group of participants known as miners who police the system. They're trying to verify transactions, sort them by time, and then when they're done, they cast a vote saying, this is what they think, this is what I think the state of the ledger is. So Bitcoin is just a ledger. It's like your bank account. It's like a spreadsheet, keeping track of who owns what Bitcoins. And so every 10 minutes, a new race begins, and these miners try to figure out, verify all the transactions. If it's not legitimate, they reverse it. The money goes back to the spender. And when they're done, they cast a vote saying, I think this is the new state of the ledger. But in order to keep you or me or anybody here from colluding and saying, hey, the ledger says I'm a millionaire, well, they make it so it's very hard to vote. And so to vote once, you have to solve a very difficult math problem. And it's so difficult now that it would be like you guessing a number, very similar to guessing a number. It'd be like you guessing a number between 1 and put a 1 with 20 zeros on the end. How long would that take you? It would probably take a few hours to guess a number between 1 and 100,000 might take you a few hours. This is an astronomically large number. You can't, and a computer does this. It's done by software. So anybody here can run the software. You install it on any machine. 10 years ago, you could do it. Now you need powerful hardware. You need a whole group to do it. But you're trying to guess this number that solves this equation so you can vote once. It's brilliant because they make it so it's easy to make the problem, super easy. It's easy to verify you did the work correctly, very easy, but it's very hard to solve it. And they also designed it so whole groups can work on it. It allows parallel processing. So you can work on a part of it and he can work on a part of it. They're called mining pools. People get together to work on this problem just to vote once. And so the idea is you have this democratic system, and it's designed so you're encouraged to do the right thing. If you try to do something against the system, you'll waste a lot of money doing it. You'll spend a ton of money to get no result out of it. If you try to hack the system
and the problem is it's tweaked for each participant for each vote, so I can't just copy the result and use it lots of times. Right?
Yeah, so each participant has your own unique identity, and it's
which is baked into solving the problem, which is why I can't copy it to get lots of votes.
And the problem, two things use electricity like crazy: input output on computers and math equations. In fact, I read an article about a kid in high school who made a heater for the bus stop by doing a fast Fourier transformation over and over and over again in a loop. I'm sure his father did that, but it's a loop, and it causes your iPhone to heat up and get physically hot, and it turns it into a heater. Well, that's what happens with the mining process of Bitcoin. And the incentive is, if you solve this equation first, if you get to vote first, and you say, okay, I think this is the state of the ledger, and most people are doing the honest thing. They just say, I think this is the state of the ledger. They're not trying to change anything. They're not trying to. They cast their vote. Then, if you're first, you win a chance. You go into a small pool, and you win a chance to get a big payout. So not only do you get a payout of 12.5 bitcoins, and by the way, when it first began, it was 50 bitcoins, and every couple of years they cut it. Every time they reach a certain number of blocks on the blockchain, they cut the reward in half. So it went from 50 to 25, and now to 12.5. And so if I finish the work first and cast the first vote, I win a chance to get a huge payout. 12.5 times 4,000 now, $4,000 each. 12.5 times that. Then you get all the transaction fees. Today, there's a new problem because this has become so slow. One of the issues with Bitcoin and blockchain is performance. And you can't buy a cup of coffee now with Bitcoin and get it to the merchant fast enough without attaching like a $40 reward to the miners. You have to attach a fee. You voluntarily do this, but if you want your transaction to be mined quickly, you have to do this now, which is a defect in the design. It's a problem now. But so buying a cup of coffee and making sure the merchant can get it in right away would cost me $40. But anyway, the miner who finishes the work first gets all that too. They get all the transaction fees too. So it's a big payout for them. But you're not guaranteed to win it. Just because you voted first doesn't mean you're guaranteed to win it. And what they do is, if you beat for Bitcoin, they set the target time at 10 minutes. The block time is 10 minutes. If you beat that, because suddenly you have new hardware or you come up with a way to do it faster, the system will adjust itself. They do an equation, and they look at how long it took to make the last block versus how long it took to make the new block, and they look at the ratio, and they adjust it. So they'll make the problem harder next time, so it does take you 10 minutes. So as computing power gets better and people group together and find ways to solve this problem faster, the problem gets harder too. And now, recently, it had to go down. They lost thousands of miners last fall when the price of Bitcoin plummeted to almost $3,000 a coin, which is the cost of what it takes to make a coin. It costs like $3,000 to make a coin, so people were leaving in droves. They lost thousands of miners. So they had to do something historical. They had to reduce the work, lower the difficulty of the problem to get people to mine it again. But the fascinating thing is this can be used for more than just currency. There's this, I came up with, over the weekend, 26 different use cases this stuff can be used for. And the idea is you have a database that can't be changed unless everybody agrees to those changes. We all have to agree. And that's pretty powerful. So now suddenly you can share a database and you can improve things like, I don't know if we're jumping ahead here, but.
Yeah. And you've mentioned stuff like we've talked about cryptocurrency, but you've voting, for example, right?
Voting is a very powerful example. So think of, and they're doing this now in Odessa, Ukraine. A couple years ago, they did their first experiments in places like hotspots like Syria. You can have a system where I can support voting, where no one can get coerced or shot or threatened or kidnapped. And this is jumping ahead, but to make this happen, one of the 4 pillars of blockchain is the ability to run a program on top of it called a smart contract. So just to give you some background, I know we're not going in order, but to give you some background, now blockchain does really 4 things. It lets you make a cryptocurrency. We've seen that with Bitcoin. It works. It's usable. The second thing is you can use it for raising money through an ICO. I can do what's called like an initial coin offering. And I can raise money without lawyers, without banks, without venture capitalists. I can issue a token for my startup, and the money goes directly to me. And everybody has proof that they have their tokens. They can't be forged or duplicated or easily stolen. They can't be counterfeited. And I got rid of all the middlemen. Now when I raise $50 million for my startup, the money goes to my business so I can hire employees. So we have cryptocurrencies, we have ICOs, but one of the core things in blockchain is data storage. So I can store data on it and it can't be erased. It's immutable. And
it's immutable, and you can track state changes.
Yes, that's the second thing too. So it's not meant for storing volumes of data. You wouldn't want to put the Encyclopedia Britannica on it. You're misusing it. You wouldn't want to put a movie on it. You're misusing it. You could, but you're misusing it. It's designed to store really proof that you wrote that document, maybe timestamps, but also it's really good at tracking minute details, minutia, like every bullet sold in the U.S. In fact, it's so good at tracking minutia that Arizona passed a law. I was all excited when I saw it too, until I read what it was about. They said we're passing a law to ban blockchain use. because it's too good at what it does. They don't want it for gun registrations, gun sales, gun ownership, because it's too good at what it does. At first I read the headline, like, oh, isn't that progressive of them? Then I'm like, they banned it. That's how good it is. But so if I write a 5,000 page book, you don't store the book on the blockchain. You store the hash code of the book on the blockchain. And then I have the private key prove that I was the first. You can prove with a private key, with a private password, that you own that book. And anybody can just look and see the hash code, and they can prove that you wrote that book. And you can prove the book was never tampered with, because the original hash code is out there for all time. And getting back to the first blockchain ever made, and back in 1990, these two guys in New Jersey, they're still doing this. Every Sunday they publish the hash code of their blockchain in the Sunday New York Times under Lost and Found. And it's I think someone began to wonder who's doing this, because it looks like gibberish, looks like random characters. They've been doing it every week for 30 years. And their theory was to tamper with their blockchain, you'd have to go and capture every copy of the New York Times on that day, get them all
for every week,
and destroy them every week. Yeah, which is hard to do. So it goes, and their first thought was you can go to Kinko's and make 5,000 copies of your will and pass it out to all your friends and some strangers too. That's a way of keeping it from being erased. But this is even better.
And I guess blockchain hasn't like arrived yet, right? It's still early
arriving,
days.
And
so like, what are some of the current issues with blockchain? You mentioned performance.
Well, I forgot to mention the fourth thing too. Smart contracts. So we had data storage, cryptocurrencies, ICOs, and smart contracts, programs that run on top of blockchain that can't be stopped, can't be censored, can't be blocked. So
like Terminator.
Right, almost. It's anyway. So now there's some problems with blockchain, and it's this can be argued, but from the very beginning, the community identified really four big things. One was privacy, then scalability, then performance, then reporting. And so they're not fast. They're terribly slow. But people trade speed and performance for a guarantee that my data is not going to be tampered with, a guarantee that my transaction is going to go through. That's worth more sometimes than speed. So people have recently asked me, can this be used for real-time systems? And there's information on the internet, people claiming that their blockchain is real-time. That's not true. It's not meant for that. Real-time means microsecond transactions. It means millisecond reaction time. Events that happen in milliseconds. It's not available yet for blockchain.
And then privacy.
Privacy is an issue too. And one fallacy is that when people use Bitcoin, you're not anonymous anymore. All the on-ramps and all the off-ramps, that's where they get you. And in fact, like the WannaCry virus, which wreaked havoc a couple years ago, they haven't gotten their money yet. They have millions of dollars that they stole from the American public by the virus would encrypt your machine, then they charge you $300 in Bitcoin to get it back. And they actually didn't unlock it for you. They didn't even do that. But they can't get their money yet because they can't get it. They need to go through an exchange. And now tainted Bitcoins, dirty cryptocurrencies are tracked now. It's very hard to convert them back to cash again. No one will touch them. So if you have your hands on a Bitcoin that came from a nefarious source, no one's going to touch it. No exchange will touch it. That's one of the beauties of blockchain. Every coin is forever traced. So it stops Ponzi schemes. It stops money laundering. It stops tax evasion, because every single coin is forever traced. Pardon?
The question about Dash coin?
Well, there's some new coins on the market that are, like Monero's a good one, right? They try to shuffle, they use what's called like a tumbler. So if I give $5 in the system, they move it around. So eventually my $5 gets replaced with someone else's $5. And that's become very popular. And so is Zcash. Zcash is trying to guarantee anonymity with something called zero knowledge proofs. And it's a technique where the best example is I can't show you the results of my math problem because you won't pay me the 20 grand you owe me. But I can show you the results of another math problem that wouldn't have been solvable if I hadn't done the first one right. And that should be enough proof for you. Anyway, long story short, that's how Zcash does it. They hide information that way with what are called zero knowledge proofs. And it's very clever. They're very time consuming to do. They're only good for certain cases. One size doesn't fit all, but all the blockchains now want to start doing that. They want to start adding zero knowledge proofs to the secret sauce to make the blockchains more for privacy, to solve privacy. If you have like if I have a program out there running on top of Bitcoin everybody can see it. In fact, a couple years ago, or actually 3 years ago, back in 2016, I made a blockchain explorer that rolled through Ethereum and reverse engineered these smart contracts to see what people are doing. They're all like hello world. They're all testing out the first example, but it's neat that you can do that. But it's also a danger too, because what if Home Depot has a deal with some big supplier? They don't want people knowing about that deal. They may not want people seeing that smart contract. And so privacy becomes an issue then. And you can't do things like encryption on these blockchains. You can't have encryption built into your smart contract. It can't handle that type of performance. It's not meant for that.
And then what about, you mentioned reporting?
Yeah, reporting, it's sort of a victim of its own success. It's like, I have a blockchain. Blockchain is this ultra secure system, like Fort Knox. But because of that, you can't penetrate it. You can't look inside because they spend all this time building it up so you can't hack it. And so something then a side effect is you can't do reporting either. So now with every blockchain experiment I've done, and I've tested quite a number of blockchains, every single one on the market now, you have to have a side database. You have to have like a MySQL database or a Mongo database or a traditional database recording metadata on the side. So you might store like, balance information for a bank account on the blockchain and account information, but on the side, you might do it again in a side database just for reporting purposes. But the source of truth, the golden source of truth would always be the blockchain. But for performance, if you tried, and blockchain's one of its great properties is I can roll back and see all the changes to my database over time. But in reality, it takes a long time to do that. You might have to sort through like 300,000 records and find the ones that belong to you and find the ones related to what you're talking about, which is very slow. If you're going to try to do reporting, a faster way to do it is just to have a side database. So I store something in the blockchain, I also store something in my side database.
It's like if you had a hash of War and Peace, you'd put the hash on the blockchain and War and Peace in a folder.
Right, you might have like some notes about the transaction. You might store that in a folder somewhere.
Like the author
and like
publish date.
In a lot of places too, they'll store things like a manuscript or document or blueprint for something. They store it on their computer and they simply store the hash code, just the hash code on the blockchain. That's all you need.
So it's like a hash code and a timestamp.
Right.
Says this existed at this time.
Then you also have the private key to prove that it matches that. So you've got the password to prove that you put it there 5 years ago. Part of it as well.
Questions, comments? Yeah, Hugh.
Where do you see combination of blockchain and AI? There's some applications.
Well,
so the question is about a combination of blockchain and AI.
Well, AI would be too time consuming. You couldn't do it with blockchain by itself. AI is more of a layer on top of blockchain. And so maybe it's a good time to introduce the analogy of the internet here.
Sure.
The internet began with Internet Protocol, IP, back in the 70s. And then they later added TCP on top of that to make it better. Then in 1989, Tim Berners-Lee added HTTP, a third layer on top. That was the first hyperlinks, hypertext transfer protocol, clickable links. And that became known as the World Wide Web. But it wasn't until 1991 that he made the first browser. But it was very rough on the edges, wasn't very, very suitable for the public. But then in 1994, Mozilla came out, the first Netscape came out. Mosaic, that's right, Mosaic. And by the way, they all have to license that. When you look at any browser, they'll still say under the about, way down, they'll reference that. You still have to give credit to that. So anyway, it wasn't until 1994 we had a very good browser to browse the internet. Then it wasn't until about 1995 that Yahoo began making like a store where you could buy stuff, search engines and stores. And so that was like layer 6, right? So it took like 5 or 6 layers before this became useful. So that's the same thing now is happening and playing out with blockchain. We're at layer 2 now. We're at about layer 2, so we're around like the late 80s, early 90s for blockchain. But down the road, there'll be layers that run on top of it. So right now, one layer that's very powerful is the idea I can run a program on top of a blockchain that can't be censored, can't be blocked, can't be stopped. And so they call those smart contracts. And so now what people do is they'll have a smart contract running on top of their blockchain, which itself is a giant stack. Blockchain, in the early days, 3 years ago, they could take 3 or 4 days to install. Hyperledger used to take like a week to install with a seasoned Linux administrator. And they found ways to make that faster with containers, and now it's a pretty quick install. But for years, you're installing layer after layer of open source technologies to make just the blockchain work. So now you have your blockchain, then you have a smart contract on top of that. Then they usually have a layer of like an API layer to support things like remote procedure calls. Then you have like your middleware. Then you have a web app that talks to that. And those web apps are now being called DApps or DApps. And there's like 4 or 5 versions, but usually it's like lowercase d, then capital APPS, so DApp. And so we're way up high now. We're many layers above blockchain. That's where AI could sit. AI could sit at maybe the high layer, like a middleware layer, or at just below the application layer. It doesn't belong on blockchain. The blockchain couldn't process the data fast enough. Well, I try to make a list. I don't know if anything on there fits that bill, but I guess
it's kind of early. But I think if you agreed upon like a data source, maybe like settling a bet or something like that, or doing some sort of analysis or prediction.
Well, one thing is the idea of blockchain. The most powerful of the 4 things I mentioned that blockchain can do is really the ability to run programs on top that can't be stopped. And the more I began to read about this, the more I got into this, I realized this is really everything. It's really everything. And with the ability to run a program on top of a platform where it can't be stopped or censored or blocked, I can suddenly replace businesses. I can disintermediate middlemen. So look at the sharing economy. eBay and Uber and Airbnb, they can all go away if you have like some smart business logic. So I think AI will be smart business logic that takes the place of what Uber does today, but it runs in a place where it can't be interfered with, where it's democratized. So the sharing economy is all about, people create goods and services and they want to trade them, usually on a website. And when you see that scenario, it can be replaced by smart contracts. And so I think that you'll need intelligence. You'll need perhaps programs that are smarter than just rules-based applications to do that. So that might be a good fit for it.
Yeah, if we can kind of to build upon that, because I know you can't go into details on this, but you built a lengthy list at Eastern Labs of more than 100 ideas that were disruptive and innovative.
We tried to, and it's easy now. We're very fortunate. Like I spent a lot of years regretting that I didn't do certain things back in 1999 and 2000 and 2001. I look back like, I looked at like dictionary.com that sold for like $150 million. Like all of us could have done that. It seems so obvious in hindsight, but I stopped, and you have to stop and pause and say, hey, it's happening again. So now there's this new platform, and Tim Berners-Lee, who is credited with inventing the World Wide Web, is now saying he believes, and others do too, that the entire internet could one day be placed on top of blockchain. And so now you'll see, in the coming years, you'll see brand new platforms where you can make apps. But not just blockchain. There's like holograms. I spent a lot of time researching the HoloLens. I'm a registered Xbox developer from the past, and when I was working at State Street, I worked on a lot of holograms, interactive 3D holograms. It's very disruptive, but there are no apps yet. No one's making any apps. There's a handful of apps, but very few apps. Brand new market for making these things. And there's also like Amazon Alexa, a brand new place where we can have conversational interfaces, natural language processing. There's a whole world out there of unwritten apps for that. But blockchain, I think, has to be the most powerful. The idea you can get rid of all middlemen. Lawyers will be affected. Realtors might be affected. It's really quite a list. And the more I begin thinking, the longer the list got. But when you go online, you'll see like the same 4 use cases over and over again. They just repeat themselves, same 6 cases. You'll never see a comprehensive list of like 30 things. I think it's got to be because they're keeping it proprietary. I can't be the only one that thought of this stuff. But it's
and we've talked a bit about kind of like the intersection of emerging versus disruptive. Like when you're coming up with these ideas or noticing these things.
Right. So there's 2 schools of thought, right? There's 3 things going on. There's the sustainable technology. You're simply improving something that was already out there. And Uber does not meet the bill. They may say they do, but the experts believe that they don't fit the bill of disruptive technology. It sounds like they do, but they don't, because 20 years ago, Silicon Valley approached the cab companies with the same idea, and the cab companies said no. So Uber is really an improvement on an existing technology. It's just incremental improvements on an existing concept and technology. Then there's emerging technologies. These are things that are just coming out now. So the third category is disruptive technologies. And it's really that if you're starting a business, it's probably not the best to pursue this unless you have a lot of funding and years of time to wait. So disruption means it's like 5 years out, 3 to 5 years out, maybe longer. Disruption usually means usually you can't identify any use cases. When you first looked at disruption, it's not obvious what to use it for. That's one of the indicators.
Like the first airplanes?
Yes. So like the Wright brothers, one of them broke his back demonstrating this contraption that they made, and no one could think of any uses. It was entertaining. They would go to like fairs and demonstrate it, but no one thought about wartime uses and mail delivery and transportation. It was too early. That's how blockchain is now.
And no airports.
No airports. And
like you didn't get a network effect.
You need infrastructure to support it, like Tesla, right? You need infrastructure to support it, or it can't happen. And it's so blockchain is very early, and that's why it's so hard to come up with use cases. 3 years ago, no one could think of anything. They thought of payments. That's a very obvious one. They thought of know your customer. They thought of voting, but there's very slowly more and more emerging. And now supply chain management became a big one. That's pretty neat because we're all sharing a database. The USDA take them up to 7 to 14 days to notify everybody about a food recall, because each company in that supply chain has their own database. Now we can all share one database. You can see, and you can digitize assets as they move along that supply chain. You can digitize real-world assets and track them along this database as they move from one person to another person through the supply chain. And so
I think of like shipping manifests.
Right. And
you send a ship, that manifest is so closely guarded and like really white glove caretaking. But if you actually signed it and had it on a blockchain, then you could verify that manifest didn't change along the way and is delivered right away.
And the power
and you can't lose it.
So we're all sharing the same database. So instantly, I stop having to make phone calls. All the faxes stop. All the meetings stop. That's why a syndicated loan can go from 60 days to 6 minutes, because you can replace people. You can use AI and automated processes to replace people that are in the loop, but also you dramatically improve communication. Because if I change something, everybody can instantly see it. I don't have to call you. I don't have to fax you. The banking industry alone was generating 28 million faxes a year just for loans. Just for loans, 28 million faxes a year to support the loan industry. That can all go away. We can share the same database, the same source of truth.
What about price, like as a form of disruption?
Well, sure. One of the indicators of disruption, usually, not always, but usually means you take something that's very expensive and you suddenly make it free. Or you make it so I can fly to Japan for $1, or I can get to Japan in 2 hours. These are examples of disruption, and blockchain is doing that now. Blockchain is allowing it so the unbanked can bank. Someone who doesn't have a bank account can borrow money now. They can transfer money now. And a good example would be payments, right? So with payments, there's a lot of companies now starting up doing the same model. The idea is I want to move $10 to my friend in Mexico. He wants it in pesos. Bank of America says $10 is too low. We're not going to take a small denomination like that. So blockchain lets me, I can go, and what the companies will do is they'll hedge it. They'll buy like 50 different cryptocurrencies. They take my $10, I can pay with a credit card. They'll buy like 50 different cryptocurrencies, and they immediately sell those 50 cryptocurrencies, and they can do an instant conversion to pesos. We hand the keys over to my friend in Mexico, so he instantly has access to his money. And now I've done 4 things. I've gotten rid of the cost of the payment. There's no expense to making this transfer, virtually nothing. Whereas Bank of America would charge it, $30 or something, or $50 or something crazy. I got it there instantly. Big banks would take days to do this. I did a currency conversion. They certainly charge you for that. And the last, and I think it's the coolest thing out of all, is you can do a micropayment. I can move 10 cents to my friend in Mexico. What bank's going to let you do that? So suddenly you open the doors now for selling goods and services. I can sell 5-cent gumballs or penny gumballs on my website. I can take a payment. I can make a profit accepting payments because the system is designed, there are no real fees. Couldn't do that with MasterCard. You'd have to be quite complex for a small guy to do that. The whole idea of micropayments. It's still a daunting problem for the big credit cards to handle that. But you've solved that. You've solved that whole, but just payments alone makes blockchain worthwhile.
And what about like originality when you're kind of thinking of like what is a disruptive or innovative thing? Like, talking about say timing, is it an old idea, a new idea?
Right, and I think nothing is original. I think every idea you have, you might think it's original, but if you get on the internet, I found going back 30 years, I found you're searching for something, but maybe not calling what everybody else calls it. When I made my screen scraping tools, I made a screen scraping app, web scraping app back in the late 90s. I was searching for web scraper, but people weren't calling it that. They're calling it data mining and calling it. There's like 10 different ways. It's like the Eskimos have like 20 words for the word snow. The same problem. But I think timing is everything, and I think Steve Jobs probably was the master of doing this. The tablet, for example, was invented back in the 90s, right? And mobile devices came out pretty early. But it's all about when you release it to the public. So Apple looks and says, okay, they're not ready for it yet. They weren't ready for it back in 1990, but in 2005 they were. And so when the first tablets came out, they were a huge success because it was all about timing.
I think of like web TV came out in the late 90s, but the content wasn't
Right.
there, the additional layers on top, right? Nobody wanted to use the internet to click on links to read text on their TV.
Right.
But now we have things like Netflix and Hulu and all the streaming companies, because the video content is there.
And inventors, I'm sad, but inventors often die broke because they're usually too soon. They have a great concept, a great idea. It's very disruptive, but it's too early. And it won't be until long after they're gone or 30 years later that it becomes useful.
And what other, we've talked a lot about blockchain, but what other kind of emerging and disruptive technology, like paradigms are you looking at in terms of like gamification or?
Sure. These are exciting times because through my history, when I went to school for computer science, and there weren't very many. It was due to limitations in like processing power. We didn't have big data sets. We didn't have open source software. Back in the 1990s, 1 mega RAM would be $10,000. So in your iPhone, you have more than that. You've got thousands times more memory than that in your iPhone. So it required a few things to happen. They had a bunch of AI winters. I know when you guys are in the AI group, they always talk about the AI winters. But there are other winters in other areas too. But now, because we've got cheap hardware, we've got big free data sets, we've got frameworks that are free and readily available, libraries, frameworks, and toolkits. Now we can start doing some of these things. And one big thing I think is holograms. And it's tricky because holograms don't always mean a viewing device. Sometimes they can be projected into a room without any devices. But things like the Microsoft HoloLens is pretty good. It understands gestures, it understands like taps, and you can speak to it. You can interact with a 3D hologram. It's not really there, but you can swear it's there. And so that's very disruptive because I can have like a 100-inch TV in every room of my house, maybe a 200-inch TV, every room of my apartment, a beautiful, brand new, thin, 100-inch flat screen TV on every wall of my apartment for a 99-cent app, as long as I have my goggles on. Don't take them off. And like you can have fine art on your walls. You can have wonderful lighting, as long as you have your goggles on. So why does that ceiling need to be real? When's the last time you touched that ceiling? Do you need to have a fancy artwork up high? It could be projected. It could be an augmented reality hologram. And traders are using it on Wall Street now because you can give it all those screens. You don't have to have 6 to 8 screens in front of them. They can interact with things more naturally. And that's why your car it has a shift stick and a gas pedal and a brake and a steering wheel. That's why they haven't moved to like a flat panel display yet. Because humans, I guess studies have shown that you're 35 times faster responding to things, spatial relationships, than you are a screen. So augmented reality, AR, brings that back. It allows us to interact with things. So a stock trader can have all his stocks laid out in front of him. Citigroup just did this a couple years ago. They made it so all your stocks lay there. The good ones bubble up, the bad ones sink down. The big ones are larger, the small ones are very small. You can reach out and tap one, open up and see what's inside, and only you see it. Or a lawyer can spread all their documents all over the floor, and only they see those documents. And AI might kick in. We thought about this at State Street. You could have AI looking over my shoulder. So I'm looking at a document. The AI is using machine learning to identify paragraphs that I need to pay attention to. Oh, look, they've got a clause in there. Make that light up in red. And that should be in red. That should be green because that's a good thing. So with no knowledge of the law, I can quickly review non-compete right there on the spot with my AR HoloLens on, my augmented reality goggles on. I look over, I can see, it can help me read a document, maybe be the lawyer that's not there for me. But I want to separate the two too. There's AR and there's VR. AR is augmented reality. It means superimposing things on your real world view, superimposing digital information on your real world view, what you see now. VR means recreating this entire world all around you. So VR is years away. It's being used in video games, but it's probably 20 years away from full implementation being useful in the business community, outside of training and things. Google Glasses was the first attempt to do AR, and it was a failure. It might have been too early. I don't think they did enough. It wasn't enough. But the Microsoft HoloLens has certainly fixed that, and it's you'll see. I think Google will try again, and Apple's trying now too. They've already released their AR kit, an AR VR kit. So they're doing both. You can make it so I hold up my phone or I hold up my tablet, and I can walk in. I can see a room that's not really there. I can step inside and look all around. You're in a prehistoric world. You can step back outside. You're back in this world again, and it's working. And that's so. But they're really testing the hardware. They're testing the APIs. They're hammering it out. And watch, in a couple of years, they'll put out a pair of goggles. And someday someone will have a pair of contacts. And it's, yes. It's more complex. Oh, like which blockchain will survive? Well, it's hard to tell, but just in the last 3 years, I've watched a lot of them disappear. It was chained. They were, a lot of people were chain was Visa was backing chain. These big credit card companies were backing chain. They're pretty much gone now. I think it'll probably be one of the open source ones. Like you look at Ethereum, they have like 600 developers actively working on it, probably more. I think you'll see one of these large consortiums do it first. But there's a lot of small companies who are trying to make their own. I've always thought there's no money in making the tools. I don't think there's really any money in making the blockchain. I think the money is in the layers on top. So the guy who makes the iPhone, that's not where the money is. The money is the person who makes the apps that run on top of the iPhone. So if you're just starting out or you're trying to start a business, I think we'll see it'll be like search engines, right? Like anything on the internet. The internet's kind of very interesting because usually it breaks the rules of normal entrepreneurship because Google entered the market very, very late. Usually winner takes all, which in that case was Yahoo. They were the first to make a search engine. So winner takes all. They're still here. They're still not gone yet because they had such an early start. But in the internet space, you can come in kind of late and still take all. But I think you'll see maybe 3 players. It'll come in maybe the government will introduce one. Again, they're still trying. I think the winner will be whoever solves privacy, scalability, reporting, performance. Whoever solves that will probably be the winner. But I think if you're experimenting yourself and you want to try this out yourself, look at the open source ones. Look at the free ones. Because most of the private ones, they simply took the code and they refactored it. They took Ethereum, they look at a hyperledger and they just refactor it. They make a spin-off of it. And so, and one of the dangers of doing that is the same thing is happening to Android, the operating system for smartphones. It's free, it's open source, but now there's over 25 orphan versions out there because no one wants to keep pace with the latest version that Google puts out. So that's happening with blockchain too. You might have 5 startups in Boston making their own blockchain, and they've effectively copied Ethereum, but they did it 2 years ago. But they haven't kept up with the changes. So Ethereum is moving forward, and they're unable to do that. And so you get the same thing that happened to Samsung and these big players. They'll spend millions of dollars improving and tweaking Android or an operating system that's free, that's open source, but then they don't want to do it again. And that's what you see happening with a lot of these startups. But I haven't seen anybody that's really solved. There's a lot of people claiming things, and be very careful. It's almost disheartening down the internet now to see all the outrageous claims. People are claiming they can do like 20 million transactions a second, and when you hear that, step away. It is not true. I don't know anybody that can do that. You're up against Google. They're trying. IBM is trying. Microsoft is trying. No one has done that yet. And if someone does claim they're doing 10,000 transactions a second, or they've solved privacy, usually it means they're doing something different. It's not a blockchain anymore. Most solutions out there are not blockchain anymore. They don't meet the core definition of a blockchain. They're blockchain derivatives. They're inspired by blockchain, but they're not blockchain anymore.
I think does JPM coin fit into that? I saw an article about that last week.
They're using a blockchain. But JPM is very interesting too because Jamie Dimon came out not long ago, really bashing Bitcoin, really against Bitcoin, saying it's dangerous, saying it's fraudulent. And then here we are, a couple of years later, they made their own coin. But what's interesting about the coin they made it so they can do faster payments to speed up payments. And all the banks, this is a very real use case for banks because, like my former employer, State Street, they're making a custody coin so that they can move money between custody banks very, very quickly without third-party clearinghouses. it wastes time and it costs money to go through third-party clearinghouses. So when you're all done doing all your transactions among the custody banks, and you want to put it back in the system, maybe back to euros or back to dollars, then you do that. But while it's inside the bank, you keep it your own currency. And it's much more efficient to move it around. And it's pegged to the dollar, of course, the whole time. But like JP Morgan, what they did is something you could do at home. I'm sure they did something fancier because they have the expertise to do it, and they have the budget to do it. But effectively what they did is they put like a small program that runs on top of Ethereum. They looked at the Ethereum blockchain, and they're running a small program on top of it called an ERC20. And ERC stands for, used to be like a enterprise request for comment. There's an old system that goes back to the 90s of they're using to sort of catalog this and track it. But it means it's a way of making your own cryptocurrency very, very quickly by taking I think it can be as short as 43 lines of code, 43 lines of Solidity code. You can make a small smart contract that runs on top of the Ethereum public blockchain that is a cryptocurrency. Now, the problem with that today is you have to spend like a couple $1 million or more to get all the exchanges on board to accept you, to recognize you, and start promoting it and marketing it. And you got to make sure that there are wallets that accept it. That's the hard part, the marketing side. But that's what JP Morgan did. They did an ERC20. Yes.
What's the main bottleneck on the blockchain stack?
And what's being done to overcome the main bottleneck in the blockchain stack?
I guess the main bottleneck
will
would be
5G help with that?
5G, not really, because it's less about like a faster. 5G will help because it'll be a faster network, right? Having a faster network is always a good thing because you can solve some latency problems that slow these things down. But the problem is I've got to get a whole group to agree to every change I make. So if I make a change, like if I call a function in my smart contract, it's going to change a 10 to a 5. Well, it doesn't stop there. That program has to run on every node of the network. So we have like 500,000 nodes on the network. My program has to run 500,000 times. They're all going to call that function to change a 10 to a 5. 500. It's going to happen 500,000 times. And when they're all done, they're going to vote the final result. And then if 51% agree, then we seal that up in a block and we say, okay, that's a frozen state now. So it's hard to speed that stuff up. It's yes.
The whole architecture is not scalable to begin with. So what are they working
Yes.
on? New architecture?
Yes, and there's some good ones. One of them, and it's I just started seeing it surface. It's very old, but it just began to surface again. And by the way, all these technologies that go back way back, even blockchain itself, they take old things and they put them together in new ways. So if you break down blockchain, there's nothing really new in it. It's just old things put together in new ways. And one of the new things that's coming out now is DAG, Directed Acyclic Graph. And they said, let's get away from no more blocks. Let's get away from blocks. There are no blocks. And the whole idea is it's all based on the parallel processing principle. So like every time you do a transaction, you've got to verify 2 previous transactions. So every time someone joins the network, every time a node gets added, every time I do a transaction, it gets faster. Unlike blockchain, which is now down to, I think it's like 3 or 4 transactions a second now, as fast as it can do. Look at Visa. I think Visa at Christmas time does 80,000 plus transactions a second during the holidays. You can't have a proper money system unless you can do that, I don't think. So, but directed acyclic graph can do that. It can easily handle, I read, like at least 10,000 transactions a second. And there are tricks to speed that up too. You can like bundle many transactions into one. Ledger's doing that. They'll put 100 transactions into one transaction. And so now they're doing 100 transactions a second.
And what do you, I've heard these DAG, the directed acyclic graph approach would be quantum proof?
Yes. So DAG is not only is it really fast, it's very fast. As more people join the network, it gets faster and faster because it's using parallel processing techniques. It's also quantum proof, and that's something you can't say about any of the blockchains out there. Most blockchains out there are not quantum proof. The minute someone has a viable working quantum computer, they're going to have to fork the whole blockchain and do something different, because the proof of work problem they'll solve it too quickly. Someone could overwrite the entire blockchain. Going back 10 years, they could overwrite all the blocks. By the way, Bitcoin is has a $40 billion market cap. So if you could do that, there's some money in there for you, you know. But when that day comes, they'll have to make a change. But right now, things like DAG are considered to be quantum proof. Quantum is not very good at solving that type of problem. It's very good at brute force problems, though, like a proof of work type problem. And there's other things on the way too that are faster. So I mentioned before proof of work, the idea is you're cranking out, you're solving a math problem. When I solve it, I get a chance to vote. There's new ones on the way too that are already in practice. There's one called proof of stake. Doesn't use any energy, much faster. You're staking money. So I might stake $10,000. I give you $1 and I'm going to put at stake 10 grand. If I screw you over, I lose my 10 grand. That's another method. It doesn't use any energy, very, very fast. Proof of elapsed time is very, very fast. There's a bunch of exotic ones too. There's proof of capacity, proof of burn, a whole slew of exotic consensus mechanisms. They're all basically based on voting that are coming out now that are much, much faster. And they're doing sharding now too. They're going to break Ethereum and the public blockchains up into shards, break it into multiple pieces. That'll speed it up a lot. They're using traditional techniques that were invented in the database community to simply speed it up.
What do you know about zero knowledge proofs and blockchain?
Well, it's pretty powerful because one of the first uses is I've got a smart contract program that runs on top of Ethereum, say, an open source public blockchain. I don't want you to see it. I don't want anybody in this audience to know what I just did. And right now, it's very easy to go through and, mind you, it's going to be you're going to get a bunch of opcodes, but you can quickly reverse engineer that into a program and see what I did. So the idea is, just to explain it to everybody, a zero knowledge proof is, I think it falls under I may be wrong, but I think it falls under the helm of NP complete problems. The idea is, I have a treasure map, or even better, you've hired me to paint your house, but you're not in Boston, you're in California, and I've got to prove to you I painted your house before you pay me. So I can take a snapshot of the front of the house, and maybe a snapshot of the side of the house, and that might be enough proof. Or let's say I mowed your lawn, you paid me to mow your lawn while you're away. I take a snapshot here, and a snapshot there, and a snapshot way back there. I'll keep giving you snapshots until I can convince you that I've mowed your lawn. But I never show you the whole lawn, never show you the whole house. The idea with zero knowledge proofs is I show you enough to prove to you I did it without showing you the whole thing. And like a treasure map, I must show you just enough so I can convince the audience I do have a treasure map without giving away the treasure map. But they do that now by trying to obscure the logic, the business logic, or the program logic in the code. But the problem with it is it's a custom solution for each smart contract. I've got to sit down, and you've got to go to work just for that one smart contract. You have your own unique smart zero knowledge proof. But things like Ethereum, they're trying to make a generic things you can use for all cases, but that hasn't happened yet. Kind of a complicated topic, but anyway, the idea is the big blockchain is all about proof. Proof you did something. And if I can show you, okay, I got the answer to the math problem was 20, and you know that answer would not have been true if I didn't solve the equation correctly. All I needed to show you the 20. I don't need to show you the work I did to make the equation.
Actually, by Macaulay.
Oh, really?
Zero knowledge proofs.
It's an old topic that's come back into the forefront again. But it's pretty exciting. It's I have a bit of a math background, but I'm really computer science. Anyway, pretty cool stuff though. One of the problems though is it's very slow. There's a lot of upfront work that needs to be done to do the zero knowledge proof. So it's very processor intensive. So it's not going to speed up your blockchain. It's going to slow it down.
I have a controversial question about proof of stake. So proof of stake means basically that if I'm a participant in my understanding, I'm a participant in a network. I have a lot of Bitcoin. I have a big server. I'm facilitating a lot of payment. And instead of burning electricity, I have this high stake, and now I facilitate a lot of transaction. I take a little cut for helping network to make transactions. What is not a bank in this? It sounds like a big bank.
Well, the whole thing could be a big bank. It's one of the first use cases for Bitcoin. The people and they remain anonymous today. Nakamoto, they went under the handle Nakamoto, Satoshi Nakamoto, but it might have been a group of scientists, and they hated the banks. This whole thing was started by computer scientists and cryptographers. Then the anarchists took it over. People that hate the government, people that hate the banks, took it over and spread word about Bitcoin. And now the banks are trying to clean it up. It's like a 3-layer cake. So keep in mind the people who invented this stuff in the beginning, they're looking for ways to get rid of the banks, to disintermediate the banks. I can have, without a bank account, with just internet access, I can now borrow money, I can spend money, I can receive money without a bank. And so in a way, it could be a bank. So much so that when I got hired at State Street, I think it was there for half an hour, and they said, what do you think about blockchain? He said, well, you do know that you could go away because of this. And they said, we know, that's why we hired you. So, they know, and the idea is to get ahead of it. First, the banks tried to stop all these things. They thought 10 years ago they could stop all the disruption by passing laws and changing rules. Now they realize they have to join it to get ahead of it. It's going to change their role.
But could the blockchain turn into a world where it basically becomes Bank of America, Wells Fargo, and UBS running the largest nodes and basically just replicating the whole centralism onto new technology? And if not, how it is going to be prevented?
Maybe, I think like in capital markets and successful markets like we have in the US, you have to have some regulation. So perhaps you'll see that might be I think you might see like someone somehow managing that. Right now it's completely open, it's completely democratic, but it's not really democratic. People like to say that Bitcoin is very democratic, but it's not really, because for a while all the mining was being done in China. That sort of takes away from that. Whoever has the fastest machine, if I can get my hands on a faster processor than you, I can take over the mining. But I think you'll see governments introduce their own cryptocurrency. They like it very much. They'll never use Bitcoin. They like the concept very much though, because tell me now I can stop Ponzi schemes and money laundering
Like collecting taxes, right?
and tax evasion, right? Pretty neat, and they like that very much. And so, and by the way, you're seeing 59 coins on the way, 60 coins on the way now that are stable coins. What does that mean? They watched what happened last year with the rise and fall of Bitcoin. That was a design flaw. And now there's 59 stable coins on the way that are going to be tied to the US dollar, tied to gold, tied to the euro. So they can never again do what Bitcoin did, that rapid fluctuation. Sorry.
Firstly, I have 2 points on that. There are ways to mitigate that. It's not just about how much stake you put in, but also how long you have. And if it's a bank, they would want the money to be circulating, not really with them. My question to you is, could you talk a little bit about like your experience with blockchain in terms of like how have you contributed to the technology or used the technology?
Well, first, just a quick thing about proof of stake. One of the detriments to it now, one of the controversies is it favors the rich. And I know that Vitalik Buterin, who created one of the founders of Ethereum, he said at some point they want to get it down so you can stake as little as $10. But right now, it favors the rich. So that's a flaw with it. But I like. I think there might be a derivative. Maybe there'll be there's other versions coming out that are kind of hybrids of that might be better. But so getting back to your question, like you said, like what have I done, right? Like I started at State Street. My first project was to digitize a syndicated loan, place it on top of a blockchain. That meant all the participants, the agent and the borrower and the lender, they all had to be represented on that blockchain. And we got into debates, and these are still happening now. They're called like cash on ledger debates. Can you put cash on top of a blockchain? We decided that, and this is the consensus now. If you're a bank and I put a 5 in that database, I can say that's $5 because I'm a bank. It's no different than an Oracle database. The Oracle databases they use now keep track of your balance. So anyway, my first project was replacing all the, and of course it was just a prototype. There's too many things in the way to make this actually work. We did all the pieces. We made it function. And we just didn't wire up to like the Swift network. We didn't actually have other banks participate. But it's just amazing how fast you can cut the time down from like 2 months down to like a few minutes. And you've got a smart contract that, and the way that a syndicated loan works is it's just a tedious process. Like we all meet, then we all sign something, then we do something else, we all sign something. It's a series. It's perfect for blockchain because it's a series of dates. So we we get the borrower gets confirmed. We find a group of companies willing to lend money to the borrower, and they all sign the agreement. First thing you do is they all sign the agreement, digitally sign the agreement, and that gets stored in the blockchain. And the beauty of digital signatures on blockchain, the magic of that is you can never say you didn't sign it. With a regular signature, I can say, no, someone must have stolen my signature. Someone forged that. With blockchain, it can be proven that you signed that. You can never say you didn't sign it. So anyway, that was my first use case. The next use case was a hyperledger test where we did we tracked derivatives, like derivative trade tracking and margin dispute resolution. And it was the idea like a hedge fund wants to borrow $100 million. They need it today because they're going to do something very quickly with it. They're going to short something. They're going to buy stock with it or something. And they State Street or a custody bank would hold the collateral. So we're going to give you $100 million, but we need something from you. We need to hold, something of equal value until you get the money back. That's called collateral management. But while you're holding that collateral, like I might hold your, like, you might lend me $5,000, but I'm going to hold on to your gold Rolex. A third party will hold on to your gold Rolex until you get the money back. But while you're holding on to that Rolex, the value of gold might change, might fluctuate every minute. And so this is very good at tracking those subtle changes to the value of that custody. But at the time, that's all they could think of. They thought of like we did a quick thing like KYC tests with blockchain.
That's know your customer.
Yes, know your customer. And it turns everyone does it first. They think it's the easiest. They think that'll be an easy one. They look at the whole list. They go, we'll do that one. Turns out to be the hardest one. It's the worst possible use case you could ever do. It's very hard because of one problem. Garbage in equals garbage out. Whatever you put on the blockchain, sure, it's secure. Sure, it can't be tampered with. It's tamper-proof anyway. But if you put garbage on the blockchain, you're going to get garbage off the blockchain. That kind of kills that use case. We learned that early on.
That's true with AI as well.
Yes. And anyway, the banks love payments just for the speed and the efficiency. They understand it. It's sort of up there in their ballpark. But I think things like voting. We talked about Odessa, Ukraine, how it can stop fraudulent voting. We can use that here in America. We can use that here. They'll do it someday, but it'll be years from now. But you could like transform the whole voting process in the United States because every citizen gets one vote. We can see who voted and when, and it's hard to beat it because it's all in one shared ledger. We can all see. But also think about corporate voting. Like, should we have a stock split? We want to vote a new board member on. We want to like hire a president. Corporate voting is they call that corporate action. It's a very powerful use case. We're getting off track, but
yeah, I mean we've been talking for quite a while. Do we have maybe one more question to wrap things up?
Is blockchain in the healthcare industry?
That's a great use case, and it's something we didn't explore because it's outside banking and finance, but I put it on my list anyway because I liked it so much. And in healthcare, there's a and I don't have a background in healthcare. I'm just going to go by my own experiences. You go and you have a test done. You see a specialist. Specialist says you got to have a test done, blood work done. Then you go to another specialist, and they said you have to have the same blood work done again. And maybe you go to a third specialist, and he or she has you do it again. Wouldn't it be neat if you could just put that all in one shared database? So blockchain is going to revolutionize healthcare because you'll have one shared database. So medical professionals all around the world can access your medical history anywhere in the world. Can't be tampered with, can't be hacked, can't be stolen. And you, the patient, have control over it. You've got private keys, you've got control over who sees my data, who can access it, and you can track when and where it was accessed, the history of when it was accessed. So think of like I went to a conference a couple years ago that touched upon some of this, and they said you'll save billions of dollars just by eliminating duplicate tests. Because this doctor over here doesn't know that doctor over here did the same exact test on you. And up until now, again, it's not that we can't share databases, but I can't trust that you're not going to corrupt it. Maybe you're not trying to corrupt it. Maybe you're not a hacker, but maybe you fat fingered something. You simply made a mistake. So that's what blockchain stops too. So if you enter a 5 when it should have been a 6, well, the blockchain will catch that too. So sometimes it's not just bad actors, but it's also just fat fingering something. So you have a shared database, a shared source of truth. Nobody can change it until the entire group votes on it. Pretty powerful concept. And I spoke to a guy in healthcare. He said, blockchain, it's so meaningless compared to this new machine that just came out that can detect cancer. Why isn't that all over the news? And I said, because you're missing the point. This is very simple. Just because it can't detect cancer doesn't mean it's going to revolutionize. I think blockchain can revolutionize healthcare in a way that cancer machine can't, because you're fixing the problem with medical records. They'll be accurate. You can see, going back from your childhood, like you'll be an adult, you can talk to a specialist, you can see your entire medical history going back to your childhood in one database. And it can never be erased. It's accessible worldwide. And nobody can tamper with it. Sorry, no big answer, but
cool. Well, we'll wrap up here. You'll hang out for a little bit if people have additional questions.
Sure.
So, thank you, Ed, for your time, and learned a lot from that. Thank you.
Thanks for having me.